In this particular lecture, I am going to show you two tools, platforms in fact, which could be used for IIoT analytics. One of these is popularly known as the R tool, which offers, it is a comprehensive tool offering different platforms, has its own language for implementation and so on. So, R is basically a tool that is widely used for analytics. So, R and another language which is known as Julia. Julia is also a very popular high level language which could be used for implementing these analytics solutions. So, both R and Julia are quite popular in the IIoT analytics scenarios and their implementation. So, let us first look at R, what is R and the R programming. So, R, it is a tool. R is a tool which offers different features of programming, so it offers a programming language, it offers a statistical analysis platform, it has graphical representation platform, data visualization, open source, its R is open source and has different data analytics features. So, these are the different features of R, and R basically has different, it's the programming environment in R supports different features. So, the fundamental concepts are like this, that there are certain reserved words in R, there are certain variables that can be defined in R, there are R operators, R data types, and these I am going to show you shortly, and what are these, and just a simple instance of all of these is what I am going to show you. So, here basically everything will be shown in the R Studio. R Studio basically has support for this R programming platform. So, I am going to show you this thing in the R Studio, but let us first proceed further and see that what are these reserved words in R. So, these there is this reserved words which have some special meaning and which cannot be used as a variable name. For example, this reserved itself. So, if you basically type in the R Studio, if you type in !, reserved or help within parenthesis reserved, this is what you are going to get. You are going to get these reserved words that are supported in R. So, these reserved words are like if, else, repeat, while, function, for, then next, break, true, false, etc. So, these are some of these different reserved words and their corresponding details are also available. So, if you just type in this in the R Studio this reserved, then you will be able to see this. Then what is a variable? Variables are basically like the variables in any programming languages. These are basically declarations that will have to be done, and these will be assigned certain values, right. So, these variables will have to be declared. For example, these are some of these variables. A is a variable, x is a variable, y is a variable. So, these variables, they could be assigned different values. So, for example, a equal to 20, 20 is the value that is assigned to this variable a. Then hello is a string which is assigned this to the value of this is a value that is assigned to this variable x, and true is a value that is assigned to this variable y. So, these are the different types of variables and how they can be used in the or they can be declared, how these variables can be declared in the R Studio platform. So, these are basically the essential features of this R programming language. So, as you can see over here, this is just a snapshot that is taken, screenshot that is taken from the R Studio, and as you can see over here, this is how you will make certain declarations, a equal to 20, and now then if you want to print a, you get this value 20. Similarly, you declare this variable x to be hello, and if you print x, then you are going to get this value, the result is going to be hello. Then true y, basically if you print y, then you are going to get this value true, because that is what this variable y is going to have this value. And also in this RStudio platform, which I am going to show you shortly, you will be able to see these different, there is a separate panel over which you can see all these global environment values of these different variables a, x and y and their corresponding values shown. Next, I am going to show you how different other things are done. For example, the use of different parameters, operators in R. Different operators such as arithmetic operators are possible. Operators such as different arithmetic operators such as the plus operator, which will do the unary plus. This minus will do the subtraction, and then star is for multiplication, slash is for division, then this cap is basically for power, basically 2 to the power x will, so you have to use this power with the cap. Then you have double percentage, which is basically the remainder of a division, and this percentage slash percentage, basically this is the division resulting in a whole number adjusted to the left in the number line. So, these are some of these different arithmetic operators that are supported in R, and this is a screenshot that is taken from RStudio. As you can see over here, it will show you the different arithmetic operators 2 plus 3, and then if you hit enter you will get this result 5, right. So, this is just a unary plus, or rather not the unary plus, but the binary. So, here actually what you are doing is you are just adding these two different operands with the help of this plus operator, and you are getting this result 5. Similarly, star is for multiplication, 2 into 3, so you get the result. Then this will be divided by 2 divided by 3 in floating point, and this is 2 to the power 3, right. So, 2 cube will be 8 and so on. So, these are these different operators that are supported in R. There are other operators, assignment operators, operators like equal to, then you have this less than sign hyphen, then you have this double less than hyphen and hyphen greater than, and their corresponding purposes are also mentioned over here. So, this is just an example. Likewise, like the previous slides, I have given you an example of all of these different other assignment operators like the equal to, etc. So, x equal to, I will just give you an example. One of these, x equal to 20 basically assigns this value 20 to x, and then if you print the value of x, you see that you get the result as 20. And the use of these different other operators are also given over here, and their examples given over here. So, you may go through and try to understand how they work. Relational operators are also possible. Relational operators like less than, greater than, double equal to, this is not equal to, and then you have greater than equal to, less than equal to, and so on, and their corresponding use and examples are also given over here. So, x greater than y, if x, y and z are configured to have these different values, corresponding values as shown over here in this variable window. So, then if you write x greater than y, obviously x is not greater than y, so you will get the value false. Similarly, x less than y true, x double equal to y false, and so on. So, then you have these logical operators like ampersand, then you have this vertical bar and this exclamation sign, and their corresponding meanings are also given over here. Ampersand is and, then this is or, and this is not. So, if these values are pre-configured to have, these variables are pre-configured to have these values like this, x false, y true, and z 4, then all of these different operators, if you use them in this manner, you are going to get these results that are shown over here, like in the previous slides with the other operators. There are certain special operators. This colon basically creates a series of numbers for a vector, then percentage in percent will help to check an element belonging to a vector or not. So, for instance, if you have this n, which is a set of 10 different integers like this, defined like this, then if you print n, then what you get is basically this particular list 1 through 10, right, and this other operator also and its corresponding example is shown over here. So, there are different data types that are supported, but before we understand these data types, we need to understand that there are different something called objects, R objects, that are supported by R. So, these are these different R objects that are supported: vectors, lists, matrices, arrays, factors, data frames, and so on and so forth. So, these different objects and the corresponding data types that are supported are the logical, numeric, integer, complex character, raw, etc. So, these together are used in order to build different complex programs that could be executed in this RStudio platform. So, this is just a screenshot once again. These are these different parameters and the different data types that are used. So, you have V which is true, then if you print class V, then you get logical, and similarly for these different other ones also it is given over here. So, what are these different R objects? So, one is this vector. So, vector is basically like a one dimensional array. So, you can have something like this, you can define a vector like this: apple less than hyphen C, within parenthesis you can give these values red, green, yellow, and then if you print apple, then what you get are these different values of this particular vector red, green and yellow. So, this is just a one dimensional array. And then you have matrices. Matrix can be defined in this manner. So, mat equal to matrix, then you define this particular matrix. So, here you are saying that this is going to be the matrix where n row, that means the number of rows is going to be 2, number of columns equal to 3, and by row true. So, that means that you are going to build this matrix by row. So, so this is just this matrix that we are going to build. This matrix will have 2 rows, these are the 2 different rows, and it is going to have 3 columns like this, and if you print this matrix, then you get A, B, C, D, E, F, A, B, C, D, E, F like this. Then you have these arrays. Arrays basically help you to get the multidimensional kind of array. So, it is like a 3D, 4D kind of array, it can be built with the help of these arrays. So, this is how to do it: A less than hyphen array, C green, yellow, dimension equal to C332, print A. So, if you print that, then you get this is this one dimension, this is the second dimension. So, this is this first dimension, and then this is the second dimension as shown over here, and these corresponding values green, yellow, green, yellow, green, yellow, green, yellow, green, and so on. So, like this is one layer and this is the second layer. You could have the third one also, fourth one also. So, you can build multiple layers of these matrices, and you are going to get a multi-dimensional array, which is over here known as the array in R. And then you have this list. List basically can be built in this manner. It is so basically the previous arrays, matrices we considered are of homogeneous type, and in the case of list you are going to have heterogeneous values. So, you can have a floating point along with integer and so on. So, you are going to have all of these built in one unit. So, this is known as the list in R. So, there are different machine learning packages that are also supported by R. The different packages for let us say random forest. There is a package which basically implements, this is a library which basically implements this random forest of machine learning. Then you have different other things like iGraph, which is for network analysis, Carry for having different functions for creating predictive models. E1071 is a package or a library which supports fuzzy clustering, SVM. Then naive Bayes classifier, etc. RPART is for building regression trees, NNet is for feed forward neural network. Like this, there are many other different packages that are supported by R. So, how do you execute these in for machine learning implementations? So, again this is a snapshot of this RStudio. So, first of all I am just going to give you an example. So, here we have this installation of the carry package. We will be using this carry package. So, we have to install it first. So, this installation is done using this particular command install dot packages carry, and then you have certain other things, or you can use install dot packages carry. This will also install this carry package or this library which has different functions already, which are already implemented. Then to load that particular package, this is this command that you are going to use, library carry, loading the data using this package. For that, loading that data, basically you can do with the help of this particular command data iris. Iris is the data set, and for example, over here as you can see, this iris data set and the corresponding values that are over here, the features are given over here. These are these different other data sets like the data set, iris, control, etc., etc. So, the corresponding values that are given over here are shown in this particular window. So, data iris will basically load the data from this iris data set, and rename the data set can be done. So, I know data set less than hyphen iris will basically rename this particular data set to data set. And as you can see over here, so this data set and iris will both have the same contents. So, then you have different other commands for cross validation, 10-fold cross validation for estimation of accuracy. These are all actually different things that you can do with the help of machine learning algorithms such as support vector machines and so on. So, for cross validation, this is the command that you use, control train control method equal to CV, number equal to 10, and the metric is accuracy. For use of support vector machine, you first set the seed. So, this is the random number seed, the seed you set first, and then basically to invoke SVM on a particular data set, data equal data set, and the methods that will be used are also specified. You use this particular command. So, fit dot SVM, this SVM command will be executing SVM on this particular data set, the name of which is data set. So, this is basically this RStudio environment platform that you can see over here. All these different data sets and their corresponding features are given over here in this particular panel. And for installation of these different libraries, you have to basically from this particular checklist, you will have to check the libraries that you want to include. So, as I was telling you, for installation this command will install the carry package. So, install dot packages carry will install this carry package over here through this particular command. So, then install dot packages E1071 will install this package E1071, right. So, this is this other package, and as you can see over here E1071, which has miscellaneous functions of the Department of Statistics, Probability Theory, etc. from TUVN, that basically will be installed, and also then if you have to want to include these libraries, then these are the commands to be used. So, library carry, this will basically help you in loading these libraries, then library E1071 will also load this library, then data iris, this data iris will basically import this particular data set, and this is going to be renamed to this data set, and then using SVM you execute the data that you have in that data set in this particular manner. So, this will be executed, SVM will be executed on this data set which has the name data set. So, what we have got is a glimpse of the R platform which is widely used for analytics. Let us now have a glimpse at the Julia programming language, which is quite popular programming language used for analytics programming, high level programming of analytics, and Julia is a popular programming language that builds on the benefits that are obtained from Python and the performance that is achieved with C language. So, it is a combination of, you can think of conceptually as a combination of benefits from Python and C. So, Julia is a open source programming language, and it supports distributed computation and parallelism, and there are different C like function calls that are supported by Julia. So, these are some of these different common programming programming features that are there. One is this println. So, this println is for printing, right. So, it is used for printing, and for example, if you type in println I am excited to learn Julia, then after that if you hit enter, you will get I am excited to learn Julia. So, this is the use of println. And then for different other variables, you can define these different variables in this manner. For example, this particular variable my answer equal to 42 type of my answer, and then if you execute this, the output will be int64. So, type of this variable is integer. So, you get integer 64 which is the type of this my answer. Then my pi equal to 3.14159, and then if you type in type of my pi, you get this floating point 64. So, these are the different outputs of this command type of. Type of is a basically command for getting the type of a particular variable, and this assignment of values to variables can be done in this manner as shown in Julia. So, the basic math functions are supported. Sum equal to 3 plus 7 will basically do the sum of two different integers which are given over here. So, 3 plus 7 10, difference equal to 10 minus 3 will give you 7, product equal 20 times 5 will give you 100, quotient equal to 100 slash 10 will give you 10.0. So, this basically will be in the floating point, and then you have power equal to 10 to the power 2. So, this cap is basically for the power. So, 10 to the power 2 will give you 100, and then modulus 101 divide percentage 2 will give you this mod value of 1. So, these are the different other operations that are supported. Assignment of strings. So, for example, you can have a string defined in this manner, S1 equal to within quotation mark I am a string. This will basically create this string S1, and then if you execute, then you get this output I am a string. So, $sign is used for string interpolation. So, name equal to Jane, number of fingers equal to 10, number of toes equal to 10, then the output will be 10. Now, if you type in println hello my name is $name, then the value of name which is Jane is going to be printed in this manner. So, similarly, printing I have number of fingers and number of toes, then you will get the corresponding values. The basically number figures will give you the corresponding value that is stored in this particular variable. So, number toes will give you this particular value that is stored for this particular variable which is 10. So, I have 10 fingers and 10 toes is what is going to be printed if you execute this particular statement. Then you have for string concatenation, you can use something like this. S3 equal to how many cats is a string, S4 is another string, is too many cats. Then string S3 comma S4 will concatenate the strings S3 and S4. Concatenate means like these two strings are going to be joined together. So, you are going to get this joint string which is how many cats is too many cats. There are different data structures that are supported in Julia. So, these are the ones that are shown over here. Tuples basically. So, this is how you can create these tuples. So, my favorite animals equal to penguins, cats, sugar gliders. This will create this particular tuple, and so the output will be, so if you execute this thing, so output is going to be penguins, cats, sugar gliders. So, like this you can build different other types of tuples as well. To create a dictionary, this is the command to be used. So, my phone book equal to dict is this particular command will create this dictionary. So, dict, then you have all these different values that are going to be stored against these different variables. So, this will create this particular dictionary named my phone book. So, then if you print this particular my phone book dictionary, then this is how it is going to look like. If you want to show a particular instance, this is the way to do it. Arrays, to build arrays in Julia, you can do it very easily with the help of putting all these array items within square brackets. So, this will create this 5 element array, my friends, having these elements Ted, Robin, Barney, Lily and Marshall. So, this one will create a 7 element Fibonacci array having these different elements over here. So, with this we come to an end of Julia. These are these different references that what I have done is basically I have given you a very high level expository view of what is R, what is Julia, how is this R Studio platform like, what are these basic operators that are there, what are the different functions that are supported in Julia and so on. So, these are the only very basic half an hour kind of glimpse of what is there. With this particular lecture, you are not expected to become an expert of R or Julia. However, if your job requires you, or if you are indeed interested to have a deeper understanding of R and Julia, you have to build your knowledge further, and you have to take different tutorials that are there for R and Julia, and you have to become master of these languages if you are required to. But from a course perspective for IIoT and Industry 4.0, I think this particular knowledge that you have been provided through this particular lecture, this will be sufficient for you at least to start with. So, these are some of these different references. If you are interested, you can go through these different references for in the future. Thank you.